Welcome back to the deep dive. Ready to dive into some more chemistry. This time we're tackling acids, bases, and pH.
Sounds fun.
I've got a whole stack of notes and handouts here
Okay.
that a listener sent in. And I gotta say, going through this stuff, acids just, they're kind of weird.
Oh, yeah.
Like they act like ionic compounds,
Whoa.
but when you look at their formulas, they look evolent.
Yeah, that's true.
Like a chemistry head scratcher, you know?
It definitely throws people off.
Yeah.
But I think once you start to understand how these things behave in water,
Okay.
it starts to make a little more sense.
Right.
And that's where I bring in our good friend, the Arrhenius model.
Oh, the Arrhenius model. Okay.
Right.
Yeah, remind me how that one goes.
Well, it basically says that when acids dissolve in water,
Okay.
they release hydrogen ions,
Okay.
those little protons, H+.
Right.
And then bases, on the other hand,
Okay.
they release hydroxide ions.
Oh, wait.
Yeah, OH.
Okay.
So it's like they each have their own signature move.
Right. And I remember those experiments in like high school chemistry
Yeah.
where you'd get out the litmus paper
Exactly.
and you'd test different household items.
Exactly. Yeah.
It was like magic watching the litmus paper turn all these different colors.
And you could really see those signature moves.
Right. Red for acids, blue for bases.
Exactly.
Yeah.
And you probably also noticed some other key properties
Okay.
of acids and bases.
Yeah. Let's see. Acids taste sour.
Right. Think lemon juice
Yeah.
or vinegar.
And they can be pretty corrosive.
They can be. Oh, yeah.
I learned that the hard way once with
Oh, no.
some vinegar and a metal tray.
Mm.
Did not end well for the tray.
And then on the base side,
Okay.
you've got that slippery feeling.
Yeah, like soap.
Like soap. Exactly.
Okay.
They can taste bitter, but I don't recommend pasting them.
No, definitely not.
And also just like acids, they can be corrosive.
Oh, okay. So handle with care.
Handle with care.
Got it.
For both.
So we've got acids and bases, each with their own little quirks,
Yeah.
their own properties.
Mm-hmm.
But then there's this whole thing about strong versus weak acids and bases.
Right.
What's the deal with that?
You can almost think of it like this. Some acids and bases,
Okay.
they're like party animals. They just jump right into the pool,
Okay.
make a big splash.
Right.
Those are your strong acids and bases.
Okay.
They completely dissociate in water.
100%.
100%. Yep.
Okay.
All those molecules break apart
Into their ion.
into their H plus or OH ions.
Okay.
One-way ticket, ionization city.
All right. So what about the weak acids and bases? Are they more like the wallflowers?
Yeah, pretty much.
Okay.
They're a little more hesitant to jump into the pool.
Okay.
They only partially dissociate.
Right.
So you've got kind of a mix of
Yep.
molecules and ions just hanging out together in solution.
So it's like a spectrum of how enthusiastic they are
Exactly.
at jumping into the water and ionizing.
That's a great way to put it.
And then, of course, we have to memorize which are the strong ones,
Oh, yes.
like hydrochloric acid, sulfuric acid,
Yep.
sodium hydroxide, potassium hydroxide.
Those are the big ones, the heavy hitters.
You get
You'll
it.
see there's a lot.
Okay.
But things get a little more interesting
Okay.
when you start to consider that some acids
Hmm.
can actually donate more than one proton.
Oh, that's right.
Those are called polyprotic acids,
Polyprotic. Okay.
like sulfuric acid.
Okay. H2SO4.
Yeah, it has two acidic protons
Okay.
to give away.
Whereas something like hydrochloric acid,
Yeah.
HCl,
Right, good old hydrochloric acid.
is monoprotic.
Monoprotic only has one proton to offer.
Okay. So it's like some acids are more generous with their protons than others.
Yeah, that's a good way to think about it.
And I'm guessing that must make a difference when we're talking about pH.
It does.
Because pH is all about the concentration of those H plus ions, right?
Exactly.
Wow, okay.
And this is where it starts to get a little mind-bending.
Okay.
The pH scale is logarithmic. Well,
Logarithmic, right?
meaning every unit on that scale represents a tenfold change
Oh, wow.
in H plus concentration.
Okay.
So a solution with a pH of 2
Right.
is 10 times more acidic than one with a pH of 3, and 100 times more acidic than a pH of 4.
So even small changes
Huge differences.
with pH can actually mean really big differences in how acidic something is.
Absolutely. Yeah.
Wow. Okay, that's pretty intense.
It's an earthquake scale for acidity.
No wonder it's so important to get those calculations right.
It is. It is.
Speaking of calculations,
Right.
my notes have some equations here
Yes.
for figuring out pH and POH.
Exactly. So you've got pH
Okay.
calculated as the negative logarithm
Yeah.
of the H plus concentration,
Yeah.
and then POH, same idea,
Okay.
negative logarithm of the OH concentration.
Right. And they always have to add up to 14,
They do. They do.
like a chemical seesaw.
Which like a beautiful balance. Yeah.
Okay. And I'm remembering now
Yeah.
that the difference between monoprotic and polyprotic acids
Right.
really matters when you're actually doing those calculations.
It does.
Like I've got an example here comparing hydrochloric acid
Okay.
to sulfuric acid.
Yeah.
They have the same concentration,
Okay.
but the sulfuric acid ends up being more acidic.
Right. Because it can donate twice as many protons.
Yeah, so lower pH.
Exactly.
It's like the sulfuric acid is that party animal
Yeah.
who brings extra drinks for everyone.
Yeah. Exactly.
They're
Exactly.
going to make the party a lot wilder.
For sure.
Now, there's also this challenge problem here.
Oh, the challenge problem.
Involving sulfuric acid and pH.
Mm-hmm.
It says it requires an extra step
Right.
because we're working backwards from a specific pH
Okay.
to figure out what the original concentration of the acid was.
Exactly.
Wait, why does that make it harder?
Well, you're going to have to use mole conversions.
Okay.
You're essentially figuring out how many moles of sulfuric acid were in that solution
Okay.
to create that specific pH.
So it's like a detective puzzle.
It is. It is.
And I'm guessing knowing whether an acid is monoprotic or polyprotic is a big clue
It's a huge clue.
in these cases.
Yeah, it tells you how many protons each molecule of acid
Okay.
can contribute
Right.
to that overall H plus concentration.
Gotcha.
It's like knowing how many scoops of flour went into that cookie dough.
Oh, I like that analogy.
Right. It changes the whole game.
Okay, so we've covered how to define acids and bases,
Mhm.
the difference between strong and weak,
Yep.
and the whole importance of pH.
Right.
But how do we actually measure pH in a lab setting?
Good question.
My notes here mention something called titration,
Ah,
and
titration.
it sounds kind of intense.
It's a key technique
Okay.
for figuring out the concentration
Okay.
of an unknown acid or base.
Okay.
It involves what we call a neutralization reaction,
Okay.
where we slowly add a solution of known concentration, that's
Yeah.
called the titrant,
The titrant.
to our unknown solution
Okay.
until we reach this perfect balance.
So it's like a chemical balancing act
Exactly.
where you have to carefully add just the right amount
Carefully, very carefully.
to neutralize things.
That's exactly it.
Okay.
And to help us know when we've reached that perfect balance,
Okay.
we use these things called acid-base indicators.
Acid-base indicators. Okay.
They're like little chemical spies
Okay.
that change color depending on the
Oh,
pH
bitch.
of the solution.
So they're like mood rings for our titration experiment.
That's a great way to think about it, yeah.
Okay.
So as you add the titrant,
Mm-hmm.
the indicator is going to change color,
Right.
signaling that you've hit the end point,
The end point.
which ideally should be as close to the equivalence point as possible.
Equivalence point.
That's where the moles of acid and base are perfectly matched.
So we're watching for that color change to tell us.
Yeah,
Okay, stop. We've reached equilibrium.
you got it.
And then we use that information to calculate the concentration.
Exactly.
This is pretty clever.
It is. It's a very elegant technique.
Okay, and you know what? Titration is actually starting to make a lot more sense to me now.
Oh, good.
It's not just some abstract concept anymore.
I'm glad to hear that.
I can actually picture it happening.
That's what we like.
Yeah,
That's the beauty of it.
we're getting it.
When you understand the principles behind it,
Yeah.
it all starts to click into place.
You know, it's amazing how much we've covered already.
I know, right?
We started with defining acids and bases, talked about strong versus weak.
Yep.
We even tackled pH calculations and titration.
We did.
I feel like we've come a long way from just staring at this stack of notes.
Yeah, we've made some serious progress.
Yeah, we have.
But there's always more to explore.
Oh, I bet.
Before we wrap things up for today,
Okay.
I want to throw out a question that's not explicitly covered in your notes.
Okay.
Something to get you thinking.
All right, hit me with it.
Okay, so we've been talking about acids, bases, and pH
Mm-hmm.
in a pretty theoretical way. How about we connect this back to the real world for a minute?
Oh, I like that.
Think about how pH affects everyday things,
Okay.
like cooking, cleaning, even your own body.
That's a good point. Like, I know the pH of soil
Right.
affects how well my plants grow.
Exactly.
And when I'm baking,
Yeah,
I always have to be careful about the acidity of ingredients.
it can make a big difference.
It changes the texture of
Yeah.
cakes and cookies.
Exactly.
Yeah.
Think about something as simple as lemon juice.
Okay.
It's acidic, right?
It is.
So when you add that to a cake batter,
Mm-hmm.
it reacts with the baking soda,
Which is basic.
which is basic, right?
Yeah.
Creates carbon dioxide bubbles.
Oh.
Makes your cake nice and fluffy.
That's why my cakes sometimes fall flat
Could be pH issue.
if I don't add enough lemon juice.
Yeah, it's all about finding that perfect balance.
Right.
The recipe.
That pH balance.
Exactly.
Yeah. And what about cleaning products?
Oh, yeah, good point.
Like, different cleaners have different pH levels,
They do.
which is why some are better for certain tasks than others,
Right. Acidic cleaners are good for
like mineral deposits.
mineral deposits. Exactly.
Oh.
Basic cleaners are better for cutting through grease and grime.
It's like choosing the right tool for the job.
It is. It is.
But in this case, it's all about understanding the pH
Right.
of the cleaner.
And what you're trying to clean.
Yeah, exactly.
Now, what about your own body?
Okay.
Ever think about the importance of pH for your health?
I know our blood has to stay within a very specific pH range.
It does. It does.
I've been like 7.4, which is slightly alkaline.
That's right. Even small changes in blood pH can be dangerous.
Okay.
Your body works hard
Wow.
to maintain that balance.
Through all sorts of complex systems.
Complex system of buffers
It's like a whole internal pH regulation team
working 24/7
working around the clock.
to keep everything in check.
Wow. So understanding pH
Mm.
isn't just about acing our chemistry exams.
No,
It's about understanding how the world works,
it is.
how our bodies work.
Absolutely, yeah.
Yeah.
It's not just knowing the definitions
Right.
and the equations.
It's about seeing the bigger picture.
It is seeing the connection.
Connections.
Yeah, that's what we try to do here.
Right. Connect the dots.
Connect the dots between the theory and the real world.
It's like we've unlocked a secret code
That's a good way to put it.
for understanding chemistry.
Yeah.
Speaking of unlocking secrets,
Oh, okay.
remember those acidic protons we talked about earlier?
Yes.
They're the key players in all this, right?
They are.
They're like the little daredevil
They're daredevils.
in the acid world,
I like that.
ready to jump ship and create all those H+ ions.
Exactly. They're the hydrogen ions that are most likely to break free
Right.
from the acid molecule when it dissolves in water.
So the more acidic protons an acid has,
Yes.
the more likely it is to dissociate in water,
the stronger it's going to be.
which affects its strength.
Yeah. It's all connected.
That's starting to make a lot of sense now.
Yeah, good.
So acidic protons
Mm-hmm.
are like the little engines driving this whole acid-base show.
That's a great analogy.
Yeah, and understanding them helps us predict how an acid will behave
Absolutely.
in different situations.
Exactly.
It's like having a decoder ring
Yeah,
for the language of acids and bases.
that's what it is.
It's like seeing the Matrix,
Oh, nice.
but instead of green code raining down,
They're all about pH and acidic protons.
it's all pH and acidic protons.
That's right.
All right, well, I think we've successfully navigated
I think so too.
the sometimes choppy waters
Yeah.
of acids, bases, and pH.
It can be a tricky topic,
It can be.
but I think you've got a solid foundation now.
I feel like we've done more than just build a foundation.
Oh, yeah.
I feel like we've built a whole chemistry castle.
Nice. I like
And
that.
it all started with this stack of notes and handouts.
That's how these deep dives work.
It's amazing, and you've been an amazing guide
Oh, well, thank you.
through this whole chemical kingdom.
The pleasure was all mine.
Really?
I always enjoy a good deep dive into the
Okay.
fundamentals,
All right.
especially when there's such an enthusiastic learner
Oh,
involved.
stop it. You're going to make me
Oh, I
blush.
deserve it.
Well, I am always eager to soak up more knowledge.
That's good. That's good.
And speaking of soaking, we did talk about
Oh, yeah.
those real-world experiments you mentioned,
Mm-hmm.
like testing household items with litmus paper.
Right?
Do you have any other fun experiments in mind? Because I'm feeling inspired to test the pH of everything in my house now.
Well, I'm no expert,
Okay.
but I do remember that red cabbage juice
A red cabbage juice.
can be used as a pH indicator.
Oh, that's cool.
It changes color depending on the acidity or basicity
Oh,
of the solution.
So it's like a natural version of the
Probably,
litmus
yeah.
paper.
That's right.
Okay. So I could test vinegar,
Vinegar,
baking soda, lemon juice,
Yep.
even soap.
all kinds of things, yeah.
All right. I'm adding that to my to-do list.
Do it, do it.
Red cabbage pH experiment.
It's a fun one.
Who knew chemistry could be so colorful?
Right. It's not all just equations and calculations.
Yeah.
It's about observing, experimenting.
And making those real-world connections.
Exactly.
It's about appreciating the chemistry that's happening all around us,
All the time.
all the time.
We just have to open our eyes and see it.
That's the beauty of the deep dive.
It is. It is.
We take these complex concepts
Right.
and make them understandable.
Break them down.
Yeah. And even, dare I say it, enjoyable.
I think so. I think so.
Absolutely. We turned a stack of chemistry notes
Yeah.
into a journey of discovery.
A chemical adventure.
A chemical adventure, that's us,
It is.
and it's all thanks to your expert guidance.
Oh, you're too kind.
I really feel like I've leveled up my chemistry knowledge today.
Good. That's what we like to hear.
I do.
The journey of learning never ends.
That's true.
There's always more to explore, more connections to make. Right. More knowledge to uncover.
Okay.
But you've got a solid foundation now, and that's what matters.
And I'm definitely feeling more confident
That's great.
about tackling those pH calculations and titration problems.
Awesome. Don't be afraid to make mistakes.
Okay.
That's how we learn and grow.
Right.
Keep asking questions.
I will.
Keep experimenting.
Okay.
And most importantly, keep that curiosity alive.
You got it. That's the heart of the deep dive.
It is. It is.
All right. Well, thanks for joining us on this episode.
It was a pleasure.
And until next time, keep diving deeper
Deeper.
and deeper.
So we were talking about titration and how we use these acid-base indicators.
Right, like little mood rings.
Yeah, mood rings for our experiment.
Exactly.
Okay, so they change color
Yeah.
when we've reached that endpoint,
The end point. Yep.
which should be the same as the equivalence point.
Ideally, as close as possible, yeah.
Okay.
That's where the moles of acid and base are equal. Okay, so we're basically watching for a color change that says,
Yeah.
stop, we've reached chemical equilibrium.
You got it.
And then we use all that information
Uh-huh.
to calculate the unknown concentration.
Exactly.
That's pretty neat.
It is a very elegant technique.
Okay, so titration.
Yeah.
It's making a lot more sense to me now.
Oh, good.
It's not just some abstract concept anymore.
Good, good.
I can actually picture it happening.
That's what we like to see.
Yeah.
When you can visualize it, it
Yeah.
really helps.
And I remember you were saying
Yeah,
it's really important to know
it is.
whether we're dealing with monoproduct or polyproduct,
Acids and bases.
acids and bases. Yeah.
Because it can really change those calculations.
Yeah, like that example in my notes
Okay.
where we're trying to figure out the concentration of a sodium hydroxide solution
Mm-hmm.
using hydrochloric acid as the titrant.
Right. And because both of those are monoproducts.
Right. It's a 1.1 mole ratio.
Exactly.
So it makes things a little easier, right?
Yeah. It does. You can use that handy-dandy equation.
Oh, yeah. Mass acid equals M base V base.
That's the one.
Okay, so at the equivalence point,
Right.
the moles of acid and base are equal.
Exactly. And you just plug in.
Plug in the knowns.
The knowns. Yeah.
The volume of the sodium hydroxide,
Mm.
the concentration of the hydrochloric acid,
Yep.
solve for the unknown concentration.
And boom, you got your answer.
That's like a chemical algebra problem.
It is. It is.
But honestly, titration is making so much more sense to me now
Oh, good.
that we've talked it through.
I'm glad.
I feel like I can actually picture it happening.
That's the goal.
Yeah, we're getting there.
We're getting there.
You know, it's amazing how much ground we've covered already.
I know.
Started with defining acids and bases.
Mm.
We talked about strong versus weak.
Yep.
Even tackled pH calculations and titration.
It's a lot.
It is.
For one deep dive.
We've come a long way from just staring at this stack of notes.
We have. We've been busy. But there's always more to explore.
I'm sure there is.
Before we wrap things up,
Okay,
I want to throw out a question
All right.
that's not explicitly covered in your notes.
hit me with it.
All right, so we've been talking about acids, bases, pH.
Mm-hmm.
Pretty theoretical, right?
Okay,
How about we connect this back to the real world?
okay,
Think about how pH affects everyday things,
okay.
like cooking, cleaning,
Right.
even your own body.
That's a great point.
Like, I know the pH of soil affects how well my plants grow.
It does.
And when you're baking,
Right.
you have to be careful about the acidity of the ingredients.
It's true.
It can change the texture of cakes and cookies.
Yeah, all about finding that balance.
That perfect balance.
Yeah, the pH balance.
Exactly.
Okay, what about cleaning products?
Oh, yeah. Good one.
Different cleaners have different pH levels,
They do.
which is why some are better for certain tasks than others.
Exactly. Like acidic cleaners are good for removing mineral deposits. Basic cleaners better for cutting through grease and grime.
It's like choosing the right tool for the job.
It is. It is.
But in this case, it's all about understanding the pH
Yeah.
of the cleaner and what you're trying to clean.
Exactly.
Okay, and what about our own bodies?
Our bodies, yeah.
I know our blood has to stay within a very specific pH range.
It does. It does.
Something like 7.4, slightly alkaline.
That's right. Even small changes in blood pH can be dangerous.
Wow.
Your body works really hard
It does.
to maintain that balance.
Yeah, through a whole complex system of buffers
It's like an internal pH regulation team
working 24/7
working around the clock,
to keep everything in check.
keeping us alive.
Wow, so understanding pH
Yeah.
is not just about acing chemistry exams.
It's not. It's bigger than that.
It's about understanding how the world work,
Exactly.
how our bodies work.
It's about the connections.
The connections, yeah.
We're trying to do that here.
Connect the dots.
Connect the dots between theory and the real world.
And I feel like it's like we've unlocked this secret code
I like that, yeah.
for understanding chemistry.
Yeah.
Speaking of unlocking secrets,
Oh, okay.
remember those acidic protons we talked about?
They do.
They're really the key players here.
They are. They are the stars of the show.
They're like the little daredevils
They're like that.
of the acid world,
Yeah.
ready to jump ship and create all those H+ ions.
Yeah. Those acidic protons are the hydrogen ions that are most likely to break free from that acid molecule when it dissolves in water.
So the more acidic protons an acid has, the more likely it is to dissociate in water.
And the stronger it's going to be.
Which affects its strength.
It's all connected, you see?
Okay, I see.
Like a beautiful web.
It's all starting to make a lot more sense now.
Good. I'm glad to hear it.
So acidic protons are like the little engines driving the whole acid-base show.
I love that analogy, the little engines.
And understanding those helps us predict how an acid will behave. It does. It does.
In different situations.
Absolutely.
Okay. It's like having a decoder ring.
It is.
For the language of acids and bases.
That's exactly right.
Like seeing the Matrix.
The Matrix I like.
But instead of all the green code raining down.
It's pH and acidic protons.
It's pH values and acidic protons.
That's right.
All right. Well, I think we've successfully navigated the sometimes choppy waters.
I think we have.
Of acids, bases, and pH.
I agree. We've done it.
It can be tricky.
But you've got a really solid foundation now.
I feel like we've done more than just build a foundation.
Oh, yeah.
It's like we've built a whole chemistry castle.
Oh, I love it.
With all the towers and turrets and everything.
I like that visual.
Yeah.
It's a good one.
And it all started with this stack of notes and handouts.
It's amazing what we can accomplish.
It is.
On these deep dives.
You've been such an amazing guide through this chemical kingdom.
Well, the pleasure was all mine.
Really?
I always enjoy a good deep dive into the fundamentals.
Right.
Especially with such an enthusiastic learner.
Oh, stop it. You're making me blush.
Well, you deserve it.
I am always eager to soak up more knowledge.
That's good.
Speaking of soaking.
Oh, okay.
We talked about those real-world experiments.
Yeah, the experiment.
Testing things with litmus paper.
Right.
Do you have any other fun experiments in mind? Because I'm feeling inspired to test the pH of everything in my house now.
Well, I'm no expert.
Okay.
But I do remember that red cabbage juice.
Oh, red cabbage juice, yeah.
Can be used as a pH indicator.
That's really cool.
It changes color depending on the acidity or the basicity of the solution.
Like a natural litmus paper?
Exactly.
Oh, so I can test like vinegar,
Yep.
baking soda, lemon juice,
Absolutely.
even soap.
You got it. Yeah.
I'm adding that to my to-do list right now.
I think you should. It's a fun one.
Red cabbage pH experiment.
That's it. Write it down.
Who knew chemistry could be so colorful?
Right. It's not all just equations and calculations. It's about observing, experimenting.
Making those connections.
Yeah, the connections.
For the real world.
Appreciate the chemistry that's happening all around us.
All the time.
All the time, yeah.
We just got to open our eyes and see it.
And that's the beauty of the deep dive.
It is. It is.
We take these complex concepts, break them down.
Make them understandable.
Yeah, and even, dare I say,
go ahead,
enjoyable.
I think so.
Absolutely.
Yeah.
We took a stack of chemistry notes.
That's right.
Turned it into a journey of discovery.
That's what we do here.
A chemical adventure.
I like it.
We did it.
We did.
Thanks to you and your expert guidance.
Oh, you're too kind.
I really feel like I've leveled up my chemistry knowledge today.
Good. That's what we like to hear.
Yeah, I do.
The journey of learning never truly ends.
That's true.
There's always more to explore.
Always more.
More connections to make more knowledge to uncover.
That's true.
But you've got a solid foundation now.
I do.
And that's what matters.
And I'm definitely feeling more confident about tackling those pH calculations and titration problems.
I'm glad.
So
don't be afraid to make mistakes.
Right.
That's how we learn and grow.
Right.
Keep asking questions.
I
keep experimenting. Yeah. And most importantly, keep that curiosity alive.
That's the heart of the deep dive.
It is. It is.
Well, thanks for joining us for this episode of the Deep Dive.
My pleasure.
And until next time, keep diving deeper.
Deeper and deeper.
I'm totally going to try that.
That's a good one. Yeah.
All right. So red cabbage.
Red cabbage.
pH experiment added to the list.
Awesome.
Who knew chemistry could be so colorful?
Right. It's not all equations and calculations.
No, it's not. It's about observing, experimenting.
Making those connections.
Yeah, the connections.
After world.
appreciate the chemistry that's happening all around us.
All the time, yeah.
All the
I
time.
just got to open our eyes and see it.
Exactly. And that's the beauty of the deep dive.
It is. It is.
We take these complex concepts
Right.
and we break them down.
Our momentum understandable.
And dare I say, enjoyable.
I think so too.
We took a stack of chemistry notes,
Yeah.
turned it into a journey of discovery.
A chemical adventure.
A chemical adventure, it's what we do.
It is. It is.
And it's all thanks to your expert guidance.
Aw, you're too kind.
I feel like I've leveled up my chemistry knowledge today.
Good. That's what I like to hear.
I have. I really have.
The journey never truly ends.
That's true.
There's always more to explore,
Mhm.
more connections to make, more knowledge to uncover.
Absolutely.
But you've got a great foundation now.
I do. I do.
That's what matters.
And I'm feeling a lot more confident about tackling those pH calculations and
Right.
titration problems.
Awesome.
So,
Don't be afraid to make mistakes along the way.
okay.
That's how we learn.
Right.
That's how we grow.
Okay.
Keep asking questions.
I will.
Keep experimenting.
Yeah.
Most importantly, keep that curiosity alive.
That's the heart of the deep dive.
It is. It is.
Well, thanks for joining us on this deep dive into acids, bases, and pH.
My pleasure.
Until next time, keep diving deeper.
Deeper and deeper.
Keep